Welcome back to the Earth Science Classroom. We're looking at mountains, looking at geomorphology, looking at the different types of mountains. Everyone thinks that mountains are just some big pile of rock that's piled up and this big, huge mass. You can climb it, and there's a great view on the top, or like a life challenge like climb Mount Everest or K2, or some other amazing mountain like El Capitan in the United States, or the Matterhorn in Europe, and that kind of thing. But the different types and how they form, they're fascinating, they are varied, and this video is going to discuss a little bit about the different types. So we're looking at what a mountain is. What is it? Okay, what defines it? Looking at the different types and then explaining the examples, their formation, their differences, obviously, between the different types, and obviously then we're going to look at some similarities. What's similar about them? Okay, so come join us now for the Earth Science Classroom. All right, so what is a mountain? So that is a general term that's given to an area of consistently high relief of a certain topography and terrain, but has a certain elevation that is consistently over 900 meters or 3,000 feet. Some articles say only between 500 to 1,000 feet is required for a mountainous area, but in general terms, it is going to be 3,000 feet. Now, the Himalayan mountains are in excess of 29,000 feet, obviously containing majority of the top 10 tallest mountains in the world, the tallest being Mount Everest currently at 29,029 feet, which is over 5 miles in the air, which is kind of crazy because there's a third less oxygen up there, and it's called a death zone for a reason. We shouldn't be up there, or humans aren't meant to be up there for a long time. So in terms of the types, there are two main types to start off with. You've got volcanic, in formation nature, and you have folded, okay? All right, so these are also called orogenic belts. So it's a consistently long line of these high elevation mountains that are formed through a certain process. And that process of formation to form these types, right? So these volcanic obviously is magma in nature. So you're going to have some magma, either a hot spot, either intrusion of the asthenosphere, or you'd have some subduction where you have flux melting and the rising of magmatic material up through the crust. Folded is through deformation. And how folded is in relation to how the rock is more ductile and folds over each other and builds on like having like a bunch of different mattresses on a bed higher and higher and higher. That the mattresses can move and they're ductile, but they're still going to layer on top of each other like you know, making the bed higher and higher and higher. Same principle here. So both volcanic and folded can be linked with collision. Okay, so how two plates are going to collide and hit each other in some sort of convergent plate boundary. And you can also link this to the Wilson cycle as well. Okay, so there are, research has shown that there's some articles suggest that there's different amounts of types. Some say 4, some say 5, some say 6. But the first one is very simple. We'll look at volcanic. Okay, so you have that mix of cooled lava. You got the In terms of the layers, you have the composite volcanoes, the shield based on viscosity. You may have some cinders or scoria, which are the very small ones in groups, and obviously maybe some hot spots as well. So in terms of Hawaii and other areas around the world. But you have these, magmatic material, either from hotspots or from subduction, creating anerogeny, which is a process of building mountains. And you have the increased or addition or accretion of layers of cooled lava and ash, depends on the volcano, but you have the growth due to consistent magma and eruptions. Okay. Next one is called fault block mountains. Now, in terms of deformation, stress and strain, because when you talk about fault and blocks being sections of rock that have moved as one to form the high elevation terrain, which we know as mountains. So fault, looking at stress, strain, deformation, and fault lines, and also looking at movement of that rock. So in terms of stress, it's going to be tension. So there's going to be pulling apart. So usually rifting is involved. So, for example, the East African Rift Valley will be involved. You have the rifting, which is the pulling apart of the brittle crust. So when that happens, there's going to be fractures occurring, and you have this consistent crust, and you have the separation, the divergence that happens, and you're going to have stretching. So here's the stress being applied. Okay, you might have some initial uplift as well, uplift of that brittle crust like this, and there's some flexure with the isostasy, and then you're going to, because it's brittle as a deformation type, it's brittle, it's going to break, and you're going to have some breaks here and some breaks here, and there's some breaks here. What's going to happen is this. On the left-hand side here, you're going to have these breaks and faults. So right here in red would be my faults, the fault lines, and these would be what's called normal faults, where the movement of the hanging wall is down, okay, with gravity. The stretches, it's being pulled, and parts of the crust are going to subside and move downwards, okay, due to that fault. So the stretching will be here, okay, and this has gone down and this has gone down. Now this creates certain topographical and geomorphological, I even say it, geomorphological features. And this is called a horst. And this here that subsided is called a raven. Like that. So you have a series of alternating horsts and gravens. These blocks of rock that have either stayed where they were, the horst has stayed where it is, but the graven has subsided and gone down. And either side of these faults, you get these valleys that are created. And you get these fault scarps. So where the rock is exposed right here, these are called fault scarps, and there's a fault plane as well. And the horst is where there is upwelling of the movement, and the graben is the downwelling of the, or downfaulted and upfaulted parts of the crust. So the example of the fault block mountains will be the Grand Teton in Wyoming, USA. Also the Sierra Nevada Mountains in also California, USA. So here are these examples of the stretching. Now this could be caused by various subduction slabs or upwelling of the asthenosphere because of subduction as a consequence. And there's a basin created because of it. Also happens in the eastern coast of the United States, in New Jersey, through various states like Maryland and Virginia, down to North Carolina, where the basin was formed. That was when the Atlantic Ocean formed, when North America split from Africa during the end of Pangea. And so, to confuse you, fault block mountains is the number 2 example in different types of mountains we're looking at. So now we're looking at type number 3. This is the dome mountains. Now, dome basically on the shape, more of a circle, looking from a bird's eye view. And this is from an uplift caused by rising material below, generally from the asthenosphere, where you have magmatic material due to convection currents moving up through the continental crust, and you're going to have this kind of like thing here where you have this dome and you have the layers of the crust and lithosphere, but also underneath you have this movement of asthenosphere. It's like a hot spot basically, but you have this kind of bulge pushing up, and because of the brittle nature of the crust, you're going to have some faults that are on the sides here. You're going to have some subsidence on the sides and some flexure right here, and obviously gravity. So you're going to have this increase in elevation, but have some faults, not so much thrust faults, but normal faults going to happen right here with the stretching as well on this dome mountain. And the example could be in East Africa with the Ethiopian highlands as well. All right, on to the 4th type. The 4th type is the erosional mountains, also called the plateaus. All right, the Plateau Mountains. Now, erosional mountains, you might think is a little oxymoron because of the opposite nature of the word erosional. Erosional is that beautiful, destructive part of Mother Nature, part of the science, whereby the breaking down of rock material into small pieces, and then obviously being transported to a different location through various erosional agents such as ice, wind, and water. Water being the most popular, most common. So mountains being formed from erosional is kind of like a hard concept to grasp. But if you think first, all right, let's have some uplift. So let's take the Himalayan mountains. Okay. All right, so orogenic belts, largest in the world, formed by India, smashed into Eurasia, India being stronger than Eurasia, so you get the crumpling effect, the thrust faults, the mixture and complex colliding zone of metamorphic rock and igneous rock. And what happens is you get the mountains going to form. All right, here's the mountain. Okay, what's going to happen is because of the collision aspect of the two plates, you have this large extent of, India's over here, Eurasia's over here. So India's going to keep pushing and crumpling into Eurasia, therefore, it's going to keep building up like this. So therefore, you have your Himalayan mountains, which are right here, this kind of like narrow strip. Then behind it, behind the Himalayan mountains, you have this big, huge plateau, which is a very long, elongated, flat area that's elevated above sea level. Now, generally it's dry because it's in the rain shadow due to the Himalayan mountains, but you have this very high, flat area, and in this case, we have the Tibetan Plateau that extends for a long area. Now, a plateau is one of the major landforms on the planet, and this kind of plateau is called an intermontane, which basically means that it's in between or adjacent to a very large mountain range. So that's one type of plateau you can have, and I'll do a video on plateaus by itself because it's very there's different types of plateaus and how they are formed. There's kind of check the video out if you could. So these erosional plateaus, first you get the movement up of the land. Now, in terms of erosional, you're going to have is you get river systems that form because you've got the obviously increase in elevation, so you've got gravity, and you start to develop the three sections or three divisions of a river system from the headwaters down to the ocean, but you get the erosional effect of water and rivers carving through these mountains of uplifted terrain, and you get beautiful features and landscapes like the Grand Canyon because of the Colorado River flowing through it. The Columbia Plateau, which is a flood basalt, which again I'll get onto that in a different video. But you have these, mountains which are carved out because of erosion by rivers, that make the mountains look more discrete, look more developed than just a simple large flat area. So now we're on to the fifth type, which is complex. Now we discussed earlier that the fault block mountains were due to tensional stress. Now complex mountains, by the name, there are a range of formations. They're usually collision based, continent meets continent, so they're obviously orogenic in nature. They form the largest type of mountains, and they are mostly associated with compressional stress, so the opposite of thrust block mountains. So compressional stress is where the rock is squeezed and you have your fault line, diagonal, your dip slip, and you have the hanging wall actually moving up, which is called a reverse dip slip fault. Now, in terms of the angle, the reverse is going to be, between 30 to 45 or plus degrees angles, whereas if you have a slighter dip, or less dip, slighter gentle fault line, we call it a thrust fault, which the average is around 30 degrees or below. So looks like this, like that. So it's very, very gentle. So this hanging wall right here can thrust up at a faster speed due to the less gravity it has to go against and the gentle slope. So it can thrust quicker. Therefore, it can build on itself and overthrust a lot easier in this situation, thus building a larger mass of mountain and increasing the root as well due to the principles of isostasy. and buoyancy. If you want to check out those two terms, I have videos for that. Check out in the top right corner for the suggestion video. It's awesome. And you get these large, very large mountain ranges. In addition to the thrust faults, you also have a lot of compression, a lot of heat, so increased pressure, increased temperature, and depth and uplift. So you do get a lot of metamorphic rocks and some igneous rocks in there as well. You do get also the presence of a lot of faults in general, but also a lot of anticlines and synclines, which is basically the up and down nature. So anticlines up there and synclines down, anticline down, in that kind of situation. So classic example is the Himalayas, the Alps, Rockies, and also the Ural Mountains. They're in Russia, Alps in Europe, Himalayas in Asia, and Rockies in the US of A. All right, so as a nice conclusion, here are the 5 main types of mountains described here. So volcanic, fault block, dome, which involves the magma, the intrusion, erosional or plateau, and finally the last one is complex. All right, so I hope you guys enjoyed the video on different mountains. Please check out the videos we're doing on the volcano playlist and different types of plateaus, Himalayan mountain playlist, and also the example of fault block mountains in New Jersey. All right, guys, thanks a lot.